So dependence and independence, I again will assume you've seen before in a previous class. And usually those are an issue of replacement or non-replacement. That's when they tend to come up. And if the probability changes each time, then it's considered dependent. So you're going to have 3 ways for determining independence, and this is the stuff that you definitely want to highlight in your notes. You must basically memorize these 3 methods. So the first one is that they are independent if, we'll put a big if here, the probability of A and B is equal to the probability of A times the probability of B. Well, I don't always have that information, so I need some alternates. So another alternate is if the probability of A given B is simply equal to the probability of A, so it doesn't matter whether or not B has happened. And then the transform version of that is if the probability of B given A is equal to just the probability of B. And so it doesn't matter which one of these you use to test, that will solely be determined by the information that you have in the prompt. But you need to know that these are all ways to check whether or not the 2 events are independent. This is not on your formula sheet, so you do have to memorize it. As a matter of fact, I warn you of this now that I will quiz you on this very thing. You have to be able to write them all out. So conditional probability, again, hopefully you've seen this in Algebra 2, but you probably didn't spend enough time to really have the concepts down. So conditional probability, the notation will look like this, and it's read the probability of A given B, which means given that B has already happened. So, for example, let's say I'm going to draw a card from a standard deck of 52 cards. By the way, if you're not sure what's in a deck of 52 cards, you can do one of 2 things. You can come in before school or at lunch, and I have cards that you can sort through to see what composes a set of cards, since card problems are used quite frequently. Or if you have a set at home, I would suggest you take them out, sort by color, sort by shapes, sort by suit, sort by what's in a suit so that you can see what's in fact in there. So I'm going to draw a single card, but with the caveat that one card has already been removed and I don't know what that card is. So if I put the card back, that first card, and I say what's the probability that the second card is an ace? Well, there are 4 aces in the deck, and I've now put that card back, so it's 4 out of 52. Versus if I don't put the card back and I got an ace, so here's the condition that I did in fact get an ace. Now there's only 3 aces left because I already have one out, and it's out of 51 because I have a card out. So you can see how the probability is different with replacement and without. That's because the without replacement, the probability is dependent. If I say, what's the probability that the second card is an ace? It will say, well, Torres, if you're holding a card in your hand because you took that out, then I need to know what that card is. So it depends. It's dependent. We'll write that up here, dependent. Versus the first one is independent. It didn't matter what I drew because I put it back. Okay, so